So this problem, which is actually example 4, it's kind of a complicated word problem in lesson 10.5. I wanted you guys to look over the weekend to be prepared and toss up a little bit of review of trigonometric ratios. So the northern lights, or aurora borealis, are bright flashes of colored light. They actually occur in nature between 50 and 200 miles above the Earth. Suppose a flash occurs 150 miles above the Earth. What is the measure of BD, which is an arc, the portion of Earth from which the flash is visible? And they tell you that Earth's radius is approximately 4,000 miles. So they have this drawn out to kind of help you. Basically, A to B, or A to D, would be 4,000 miles. You would even have this bit here to the end of the world would be 4,000 miles. Then you have this portion here, which is another 150, which makes this whole total of AC 4,150. So what I want to do is I want to kind of take this cross section here, okay? And I'm going to write, to help you out here, triangle A, B, C. AB is 4,000 and BC is 4,150. Now, in order to solve this problem with trigonometry, you do not actually have to find the length of BC. But I'm going to do a little bit longer version of this problem, and I'm going to show you that if we find this and then we use different trigonometric ratios, we're always going to get the same answer. Because I think that part of the problem you guys had with the trig ratios is knowing what to use when. So I want to find BC. I know that 4,150 squared is going to equal BC squared, which I'm going to call X, plus 4,000 squared. 4,000 squared I know is going to be 16 and 6 zeros. So I'm going to put that over to the side. We're going to get some very large numbers into this calculator in a minute, so I want to have stuff kind of written out. So the first thing I need to do is take 4,150 and square it. I get that number. Now I'm going to subtract 1, 6, 1, 2, 3, 4, 5, 6. And I get that number. I want the square root of that number, and I get 1,106, roughly. So I've now found the length of AB, BC, and I had AC. In order to find so, I'm going to erase some of what I wrote here. Remember, this was my original problem. This is triangle ABC. Triangle ACD is going to be congruent, okay? Side, side, side. They're both 4,000 base, 4,150 hypotenuse. This third measure is going to be 1,106. So if I can find the measure of angle A, this is a central angle, I will have the measure of this part of the arc. Then I could double it, that would be that angle. I'd have the measure of that part of the arc. So I want to use trigonometry to find angle A. So from trigonometry, you'll remember I told you they're so it's an H, sorry, TOA. In this case, I can set up either that I can set up the sine for angle A, the cosine for angle A, or the tangent for angle A. So if I decided to find the sine of angle A, that would be the opposite over the hypotenuse. If I asked you to find the cosine of A, that would be the adjacent over the hypotenuse. So the adjacent is 4,000. Waiting for that to write. The hypotenuse is 4,150. If I asked you to find the tangent of A, the tangent is opposite over adjacent. So the first question would be, could you set all of those up? If I said sine of A, could you remember, oh, that's the opposite side over the hypotenuse. If I said, could you find the cosine of A? Could you remember that's the adjacent side over the hypotenuse. And if I said find the tangent of A, would you remember be able to set up the opposite over the adjacent? These are three ratios. I'm going to show you in a minute that any three of these will actually end up giving me the same number, the same angle measure. It's just a matter of which ones I use. Had I not found 1,106, I could have said, oh, I have the adjacent and I have the hypotenuse, so I'm going to use the cosine ratio. So sine, cosine, and tangent just mean a ratio. We're going to talk in a minute more about what that means. So I'm just going to do this math here. 1,106 divided by 4,150 equals 2,665. The sine of A is 0.2665. That doesn't help us at all yet. The cosine of A, 4,000 divided by 4,150 is 0.9639. Still doesn't help us yet. The tangent of A, 1,106 divided by 4,000, 0.2765. That still does not mean anything to us. A lot of what we did, and we're going to use this in a minute though to make some sense, but a lot of what we did in chapter 7 on tangents was just figuring out how to set them up and how to get a number. The number doesn't mean anything to us until we use inverse trigonometric ratios. So when I take my calculator and I put in 0.2665 second, and then I do this symbol here, which means the inverse sign, I get 15.456. That's going to round to 15.5. So I'm going to go ahead and put that. That's the inverse sign. Now the inverse sign of 15.5 means when I have an angle A, that has a sine ratio of 0.2665, the measure of that angle is 15.5 degrees. Going on to the cosine ratio. I said the cosine ratio is 0.9639. What I actually need to do is use the inverse cosine ratio. What that means is when I say I have an angle, A, that when I take the adjacent side and divide it by the hypotenuse, I get 0.9639. So when I have an angle A that has a cosine ratio of 0.9639, what angle measure does that equal? So 0.9639, second degree, and this time it's cosine. 15.44. Pretty close to 15.5. And now, when I have an angle A that has a tangent ratio of I want this one. 0.2765 inverse tangent. That also is 15.456 or 15.5. So all of these, I am only doing math to get a ratio. Then I need to put it into the calculator to say when I have that ratio, that equals an angle with what measure. And I get that the angle measure is about 15.5. Remember, as I said in the beginning, had I realized initially, or had I felt you guys were comfortable realizing initially that this would be cosine ratio, I would not have had to do these others. I would have done cosine ratio and I would have gotten 15.4. So either way, let's say 15.4. If this is 15.4, that's 15.4. And 15.4 times 2 is 30.8 degrees. I believe the book tells us 31 degrees. Okay? The book does a lot of work there. Some of the students said, well, the book doesn't do it the same way you did. The book really does it the same way I did. It actually says solve right triangle CBA to find the measure of BCA. Okay? So they use solving the right triangle to find the measure of BCA. Back here. BCA. I could have found the measure of that, but if I found the measure of that, then I had to use interior sum theorem to say, well, 90 plus this, what would be left over? So, and that's actually what they ended up doing here in the book. I'll show you. They did 360 minus. So I did it slightly differently, but you still had to use, no matter how you do it, you have to use trigonometry ratios. I hope that this part here, spending the extra time, helps you understand how to calculate the ratio and then how to use the inverse function on your calculator to find what angle measure that ratio correlates with.